Right now, there is a machine humming in your kitchen. It might be the most ignored appliance in your house, but it runs on a technology that is nearly 100 years old. It relies on moving parts that wear out over time, and chemical gases that can slowly leak into the air. But over in a lab in Beijing, a team of scientists has built a new kind of cooling machine that has almost no moving parts. It uses no compressor, no chemical gases, and no loud humming. Instead, it uses ordinary magnets and a block of metal to squeeze heat out of the air. If this invention works at a large scale, the refrigerator sitting in your house right now could become as outdated as an ice delivery truck from the 1920s. This is not science fiction. It is a real breakthrough in physics that could completely change how we keep our food cold, how we air condition our homes, and even how we cool down the battery in an electric car. If you are enjoying videos like this, please hit the like button because it takes a lot of effort to make these, and subscribe so you do not miss the next one. The technology hiding inside this new machine is incredibly simple to understand, but it took scientists over 100 years to figure out how to make it work properly. The scientists in China have finally solved a puzzle that has frustrated engineers for decades. They found a way to remove the bottleneck that kept this amazing idea stuck in the laboratory. What they built is a completely solid-state refrigerator, and it could be the start of a quiet revolution in home appliances. But to understand why your current refrigerator is about to become ancient history, you first need to understand exactly what is hiding inside it right now. The old machine in your kitchen. Think about all the machines around you that keep things cold. The refrigerator in your kitchen, the air conditioner in your window, the cooling system in your car, the freezer at the local grocery store, and even the machine keeping vaccines cold at the pharmacy. They all run on the exact same idea. It is a process called vapor compression refrigeration. It was invented back in the 1800s, and it has dominated the cooling market for almost a century without changing very much. It is one of the most quietly important inventions in modern life. Without it, we would lose food safety, medicine storage, and livable indoor temperatures in hot climates. Yet, almost nobody stops to think about how it actually works. Here is how it works in simple terms. The machine takes a special chemical gas and squeezes it into a very tight space using a mechanical pump called a compressor. When the gas gets squeezed, it gets very hot. The machine pushes that hot gas to the back of the fridge, where the heat escapes into the room. Once the gas cools down, it turns into a liquid. Then, the machine lets that liquid expand into a larger space. When it expands, it absorbs heat from the inside of the fridge, making the air cold. Then, the cycle repeats over and over again. It is a clever system, but it has some big problems. That compressor is a mechanical part. It pumps up and down constantly, which is why your fridge hums. Because it moves so much, it wears out over time. That is one of the main reasons refrigerators eventually break down and stop working. To make cold air, that little compressor is running constantly, using electricity and wearing down its moving parts. It is like a tiny engine running 24 hours a day, 7 days a week, right next to your food. You do not hear it most of the time, but it is always there, pumping gas through metal tubes. But the bigger problem is the chemical gas inside the system. Those gases are sealed inside the pipes, but they leak out slowly over the years. Some of these chemical gases are incredibly bad for the environment. For example, one of the most common refrigerant gases used today is called R134A. According to industry research from the Rocky Mountain Institute, this specific gas has a global warming potential about 1,430 times that of carbon dioxide. That means if just a tiny bit of it leaks out of your fridge, it traps heat in the atmosphere much more than the exhaust from a car. If you multiply that by every fridge, every air conditioner, and every freezer on the entire planet, you start to see why scientists have spent decades trying to find a better way to cool things down. It is a global problem hiding behind a kitchen door. When you think about the millions of new refrigerators sold every year, the amount of chemical gas inside them is staggering. If we can find a way to cool things without those gases, we can make a huge dent in global warming. That is why this race to build a new kind of fridge is so important. The machine in your kitchen is quiet, but it is secretly working hard and slowly wearing out. It relies on a 100-year-old idea that uses moving parts and chemical gases. This is exactly why a team of physicists in China started looking for a completely different way to make things cold. They knew they had to get rid of the compressor, the moving parts, and the chemical gas. The world needed a machine that could cool things down without destroying the environment, and the answer was not going to come from making a better compressor. To find their answer, they had to look back at a physics trick that was discovered way back in the 1800s. A 100-year-old idea finally wakes up. Scientists have known since the year 1881 that certain materials have a strange reaction to magnets. If you apply a magnetic field to a specific piece of metal, that metal actually heats up. If you remove the magnetic field, the metal cools down. This process is called the magnetocaloric effect. It is a real physics phenomenon, and it does not require any moving parts or chemical gases. It is a completely different way of thinking about temperature. This magnetocaloric effect was a curiosity for a long time. It was a neat trick that physicists like to talk about, but nobody knew how to turn it into a useful machine. The idea of using magnets to cool things down seemed impossible because the effect was so small in most natural materials. You could heat up a piece of iron with a magnet, but it would only get a fraction of a degree warmer. It was not enough to freeze water or keep milk cold. That is why it took so long for someone to find the right kind of metal. To understand how it works, think about a simple rubber band. If you take a rubber band, stretch it out very fast, and hold it against your lip, it feels slightly warm. You changed its shape, and that sudden change created a tiny bit of heat. Then, if you let the rubber band snap back to its normal size, it feels cool against your lip. Certain metal alloys do something very similar, but instead of stretching them physically, you use a magnet to stretch their atoms. When you bring a strong magnet near this special metal, the magnetic field forces the atoms to line up in a neat, orderly line. This sudden atomic movement creates heat, and the metal gets warm. Then, when you take the magnet away, the atoms go back to being messy and unorganized. When they scatter, the metal pulls in heat from its surroundings, making the area around it cold. You can do this over and over again, millions of times, and the metal never wears out. It does not leak gas, and it does not need a loud compressor. It is a perfectly clean way to create cold. In 1976, a physicist named G.V. Brown decided to build a working magnetic refrigerator using this exact idea. He used a rare earth metal called gadolinium. When he brought a strong magnet close to the gadolinium, it heated up. When he moved the magnet away, it cooled down. It worked. It was the first time anyone had made a magnetic refrigerator work at room temperature. It was a massive breakthrough that proved the concept was real. But for decades after that, magnetic refrigerators stayed stuck as clunky laboratory prototypes. They never made it into kitchens. The reason was a frustrating engineering problem. When the metal gets cold, you have to move that cold air to the inside of the fridge where your food is. In older magnetic refrigerator designs, engineers ran water or some other fluid past the cold metal to carry the heat away. The fluid acted like a middleman, carrying the cold from the metal to the food compartment. But water is very slow. It takes time to flow past the metal, absorb the heat, and flow back. This slowed the entire cooling cycle down. It wasted a lot of the cooling effect, and it meant the magnetic refrigerator was not powerful enough to compete with a regular kitchen fridge. The fluid became a massive bottleneck. Imagine trying to cool down a hot drink. If you just blow air on it, it cools slowly. If you put an ice cube in it, it cools fast. But if you have to wait for water to carry the cold to the glass, it takes too long. That was the problem with the old magnetic fridges. They were waiting for water to do a job that should have been instant. The Chinese team knew that if they wanted to make a fridge that could replace the 100-year-old compressor, they had to get rid of the fluid completely. They needed a way to move heat instantly, without relying on a slow liquid. The Beijing lab and the solid solution. A team of physicists at the Institute of Physics, which is part of the Chinese Academy of Sciences in Beijing, decided to tackle this problem head-on. They asked a very simple question. What if, instead of using a liquid like water to carry the heat away, the heat moved directly from solid to solid? What if they built a machine with absolutely no fluid at all? This was the key to making the technology work. They wanted to cut out the middleman entirely. Their research was published in a journal called The Innovation in May 2024. The team, led by researchers including Yuan Lin, Jing Wang, and Baogen Shen, described building a device they call a hybrid magnetic regenerator. It is a completely new way of thinking about cooling. Instead of having water flow past the magnetic metal, they took the magnetic material and layered it directly against a different solid material that conducts heat incredibly well. They packed these materials together so tightly that heat could move from one to the other with absolutely no middleman. There were no pipes, no pumps, and no fluid to slow things down. The Chinese team knew they had to be clever. They could not just use any metal. They had to find materials that reacted strongly to magnets and also transferred heat perfectly. They experimented with different alloys, mixing metals together until they found the perfect combination. When they finally pressed the magnetic alloy against the heat-conducting material, the results were stunning. Heat moved instantly. There was no delay, no wasted energy, and no fluid to pump around. It was a completely solid-state machine, meaning everything happened inside solid blocks of material. This was the missing piece of the puzzle. According to the study, this fully solid-state design completely removed the frequency limit that fluid-based systems were stuck at. In plain terms, because there is no slow fluid to wait for, the device can cycle much faster. It can apply the magnet, remove the magnet, apply the magnet, and remove the magnet at incredible speeds. This means it can move much more heat in the exact same amount of time compared to older prototypes. It is like upgrading from a slow drip of water to a high-speed river of heat, moving instantly from one solid block to another. By removing the fluid, the Chinese team closed the gap between an interesting lab idea and something that could actually compete with the refrigerator sitting in your kitchen. This solid-state design is completely sealed. It has no moving parts to wear out and no chemical gases to leak into the atmosphere. Because it is just solid material touching solid material, it is incredibly quiet. It does not hum. It does not vibrate. It just sits there and moves heat using invisible magnetic fields. This solves almost every problem with the 100-year-old vapor compression system. It is safer for the environment because there are no greenhouse gases. It is quieter for your home because there is no mechanical compressor pumping up and down, and it is more durable because there are no moving parts to break. But the team in Beijing quickly realized that what they had built was much bigger than just a better kitchen appliance. They had accidentally created a completely new way to move heat, and it was about to open doors they never expected. The engineers were not just thinking about your kitchen. They were thinking about the future of technology. If you can move heat perfectly with no moving parts, the possibilities are endless. The same technology that could make your kitchen fridge obsolete was about to solve a massive problem in the modern technology world. Beyond the kitchen icebox, the Chinese Academy of Sciences team did not stop at making a better refrigerator, because their new design needed no pipes, no fluid, and no seals that could leak. They started experimenting with how else they could use it. In a newer paper published in the journal PNAS, they showed that this solid-to-solid heat transfer can be aimed at very specific points, almost like a heat scalpel. You can use it to cool down a tiny, exact spot without cooling down the area around it. This discovery matters far beyond your kitchen. Modern electronics are getting smaller and more powerful every year. The tiny chip inside your smartphone, the large battery pack in an electric vehicle, and the massive servers inside a data center all generate heat in tight, specific spots. If those spots get too hot, the machine stops working or catches fire. As devices get smaller, getting rid of heat becomes one of the hardest problems in engineering. Cooling those hot spots efficiently is a growing headache. Right now, engineers use bulky compressors and tiny refrigerant lines to try and cool down electronics. But those lines can leak, and the compressors take up too much space inside a small phone or a sleek laptop. They also use fans, which blow dust around and make noise. The solid-state magnetic system changes everything. Because it has no fluid, it can be shaped and placed exactly where the heat is generated. Imagine a tiny magnetic cooling device attached directly to a computer chip. As the chip gets hot while you are playing a game, the magnetic device turns on, pulls the heat away instantly, and keeps the chip at the perfect temperature. No fans, no loud humming, no chemicals. The same solid-state system that keeps your milk cold could keep your phone from overheating. It could keep the battery in an electric car from getting too hot on a summer road trip, which would make the battery last much longer and charge faster. Think of a traditional air conditioner. It is like trying to cool down a whole room by blowing air over a block of ice. It works, but it is clumsy. You are cooling everything, even the parts that do not need it. The new magnetic system is like putting a tiny ice cube exactly on the one spot that is hot. It is precise, it is fast, and it uses very little energy. This precision is what makes the Chinese invention so exciting to the tech industry. It could even cool down the giant servers that run the internet without using massive amounts of electricity and water. Data centers use huge amounts of power just to stay cool. If they could use solid-state magnetic coolers, they could save energy and save water at the same time. What started as a better way to build a fridge is turning into a general-purpose tool for managing heat. The researchers realized that their solid-to-solid design could completely change how we build and cool modern technology. This solid-state technology is so versatile that it could end up in places you would never expect. Imagine a spaceship that needs to cool its electronics without using noisy fans or leaking fluids in zero gravity. A solid magnetic cooler would be perfect for that. Or think about medical devices, like a tiny implant that needs to stay cold to preserve medicine inside the human body. With no moving parts, it would never wear out or vibrate. The possibilities are endless, and it all started with a team trying to build a better fridge. But moving from a brilliant idea to something you can actually buy is not easy. They had built the prototype, but there were still massive hurdles standing in the way of this machine ever reaching a store shelf. They had to prove that their invention could be built cheaply enough to compete with the old 100-year-old technology. The hard road from lab to store. It is important to be honest about where this technology actually stands right now. What the team at the Chinese Academy of Sciences built is a laboratory prototype. In their scientific paper, they describe it as a conceptual device. It is not sitting on a shelf at an appliance store, and there is no announced timeline for when you might see it for sale. Magnetic refrigeration, as a category, still has real hurdles ahead of it before it can replace your kitchen fridge. The biggest hurdle is cost. The magnetic materials involved, like the gadolinium alloys used in the lab, are much more expensive than the chemical gases used in ordinary fridges. Gadolinium is a rare earth metal, and mining it is difficult and costly. On top of that, building the strong, compact magnets needed to make the effect work adds even more cost. You cannot just use a cheap refrigerator magnet. You need powerful, specialized magnets that can create a strong enough magnetic field to change the temperature of the metal. Across the entire solid-state cooling field, researchers and journalists covering the space have noted that current systems often still cost more to build than a standard compressor fridge. In many cases, these early prototypes also run less efficiently than a standard compressor. They use more electricity to do the same amount of cooling. The wall between this new technology and the consumer market has not disappeared. It has just been moved further down the road. The Chinese team solved the fluid bottleneck that held magnetic refrigeration back for decades, but they still have to solve the problems of manufacturing, cost, and overall energy efficiency. They have to figure out how to make these machines in a factory for a price that families can afford. If the new fridge costs 5 times more than a regular fridge, nobody will buy it. The technology has to make sense for regular people, not just for scientists in a lab. However, this research is a genuine step forward. Every major technological revolution starts exactly like this. It starts in a quiet laboratory with scientists asking a simple question: what if we take away the fluid? What if we use magnets instead of moving parts? The work done by Yuan Lin, Jing Wang, Baogen Shen, and their team at the Institute of Physics in Beijing is pushing the boundaries of what is possible. They proved that solid-to-solid cooling works, and they opened the door for engineers all over the world to improve on their design. The scientific community is paying close attention to this breakthrough. The Chinese team has proven that the concept works at a high level of efficiency. Now it is up to engineers and manufacturers to figure out how to scale it up. This is how every major technology starts. The first computers were the size of a room and cost millions of dollars. The first solar panels were incredibly expensive, but over time, engineers figured out how to make them smaller and cheaper. The same thing will happen with magnetic refrigeration. One day, you will walk into an appliance store, and the quietest fridge on the floor will not have a compressor at all. It is a strange thing to sit with. The fridge humming in your kitchen right now runs on essentially the same core idea as one built in the 1800s. And yet, a few labs quietly working with magnets and metal alloys might be building the thing that finally replaces it. Not with something flashy, but with something quieter, simpler, and if the engineering holds up, kinder to the planet. Technology like this rarely arrives all at once. It arrives in small, unglamorous steps. In papers most of us never read, years before it shows up in a store. But one day, the loud humming fridge in your kitchen might be a thing of the past, replaced by a silent block of metal and a magnet. If you enjoyed this story and want to see more like it, hit the like button, subscribe, and turn on notifications so you never miss the next one. There are related videos on the screen right now if you want to keep watching. So here is a question for you. Which everyday machine around you right now do you think is next in line to quietly disappear? Let me know in the comments.